Well, what do you notice about the first two right here? They're already solved for y. Okay, so if you put on this one, y equals mx plus b, you'll notice that the 8 is my slope, and what's my y-intercept? I don't see one. What's understood? Plus what? Y equals 8x plus 0. So, do I have a y-intercept of 0? Okay, yes I do. So, it is a direct variation, so I'm going to put dv for direct variation. But it also says identify the constant of variation. You remember what the constant of variation is? Look at your notes. Constant of variation is, oh hey, it's the slope. Okay, well what's the slope of this problem? Okay, so instead of saying m equals 8, we're going to say k for my constant of variation is equal to 8, and we're finished with problem number 1. It is a direct variation, and the constant of variation is 8. Again, that's the slope. All right. So as we go ahead and look at the other ones, and again, the minute you find out that your y-intercept is not 0, you just simply say not a direct variation, and if it's not a direct variation, you don't have to worry about finding k. You can only have a constant of variation if you have a direct variation. Okay? Now, what are you going to have to do over here? You're going to have to put it in slope-intercept form. You're going to have to solve for y. You remember how to do that? You're going to have to take this 3x and move it to the other side. Make a 0 pair with that. Okay? Go ahead and give those a try. All right, if we look over here at the next problem, it says graph the direct variation equation. Okay? So we need to solve for k. Okay? So as we take a look at that, let's go ahead and solve for y. Solve for k. That making sense there. All right, so solving for y, this one's going to be pretty easy. Let's divide both sides by 3. And so now my equation is y is equal to 4/3 x. Now, if they tell me it's a direct variation, what do I already know? What point on the graph do I already have? All right. It says a direct variation, it always goes through the origin. You tell me I have a direct variation, I'm going to put a dot at the origin. Yeah, let's put a dot at the origin. Now again, the only reason I can put a dot there is because they tell me direct variation. All right, so do I know my rise and run? Hopefully I do. I know that I'm rising 4 and I'm running to the right 3. So from this point, I'll go up 4 and right 3, and I'll put a dot. Remember, if you can't go up and right, you can go down and left, because a negative over a negative is also a positive. So now we have these points, and we can connect them, and guess what? We have graphed the line. Okay? So you can do the same thing on the other one. 5 and 6, go ahead and solve for y. If you want to, you can already go ahead and cheat. Direct variation, you can go ahead and put a dot right there in the center, and you can go. All right, so let's look at the next one. Number 7, the graph of a direct variation equation is shown. How do we know? Well, it looks like that this one goes through the origin, that one goes through the origin, and so does that. Yep, all direct variations, they all go through the origin. All right, it says write the direct variation equation. Okay, now if you remember, we said that the direct variation is going to be what? Y equals k times x, where k is the slope, right? Okay, so y equals kx, or the slope times x. Can we do a rise and run triangle or a slope triangle from the origin? Ooh, that's a big highlighter. Okay, so let's just start at the origin. We go up 6 and right 1. That is 6 over 1, which is simply 6. All right, so there is my direct variation equation. And now it says find the value of y when x equals 10. So now I'm going to come over here and say, all right, if x is 10, I'm going to plug in a 10 right there. So y is now equal to 6 times 10, which is 60. So I have two answers. I have the equation they asked for, and I have the value of y whenever x is 10. Okay? Let's do another one of them. Let's just do number 8. All right, so again, we know it's a direct variation, so we can start y equals k times x. We know k is the slope. I have 2 points, so let's do a slope triangle. This should all be fairly familiar to you. We're going to go from the origin, we're going to go up 5, so that's positive 5, and left 2, so that's negative. So y is equal to negative 5 over 2 times x. That is my direct variation equation. Right? And so now we're going to plug in a 10 right there. You can use your calculator if you want to. That's a negative 2.5. So y is going to be equal to negative 5 halves times 10. And that's going to be negative 25. All right, so whenever x is 10, y is a negative 25. Okay, so you can go ahead and do the other 9 through 12 the same way. All right, so 13 through 16 says to tell whether the table represents a direct variation. If so, write the direct variation equation. All right. So, y'all remember on number 4, it says the ordered pairs of a direct variation are proportional. All right, so that's how we're going to check it. We're not going to try to graph these things right here. We can go ahead and start looking at some of these right here and see if they're proportional. Okay, so I'm going to start with the easy one. I'm going to start with this guy right here and say, okay, this ratio, okay, remember, k is y over x, so I'm going to put my y over my x. So I'm going to take 18 over 1, that's this point right here, and then I'm going to pick another point right here, and I'm going to put y over x, and I'm going to ask myself, are they equal? Are they proportional? Okay, well, that's a negative 2, sorry. So what is 18 divided by 1? Well, that's obviously 18. What's negative 36 divided by negative 2? That's also 18. So this is true. Now you can't just stop with 2. You need to go ahead and check the other ones as well. So I'm going to check another one right here. So what about y over x on this one? What is 54 divided by 3? You got a calculator, right? 54 divided by 3 is 18. Hey, look, all of these things right here, all of these ratios, go ahead and check these other two. You'll find out 9 divided by 0.5 is 18, and negative 144 divided by negative 8, 18. All of these ratios equal the same thing. In this case, it's 18. So if I cross-multiplied each and every one of these, 1 times 54 is 54, 18 times 3 is 54. They would all be true. So is this a direct variation? Yes. And what we get, you remember what k was equal to? K was equal to y over x. So we already found k. K is 18. And if we want to write the direct variation, look at your notes. Direct variation, y is equal to k times x. So if I tie all this stuff together, in this case, y is equal to 18x. And you can check it out. 1 times 18 is 18. Negative 2 times 18 is negative 36. 3 times 18 is 54, and so on. Okay? Now, let's try another one here. So, as I take a look at, I don't know, let's take a look at 15. One down here. I'm going to start with the easy ones first. I'm not going to mess with the decimals here, because if I find just one that doesn't work, I don't have to check the other ones. So, if I take y over x of this one, I get 4 over 14. And if I take this one right here, again, y over x, I get 28 over 2. Well, if I cross-multiply these two guys right here, hopefully you can see 4 times 2 is 8, and 28 times 14 is sure a lot more than 8. I'm just going to say it's not 8. So these guys are not proportional. Well, if they're not proportional, that doesn't mean it. That means that this graph does not go through the origin. It's not a direct variation. Okay? So 13 was a direct variation because all of my ratios of my ordered pairs were the same. So I was able to write an equation. This one right here, we're simply going to say it's not a direct variation, not DV, direct variation. Okay? So do I try to find K or do I try to find the equation? No. If you don't have a direct variation, you can't find the value of K. Okay? Go ahead and try 14 and 16 as well. All right. On the back. Now these, I think, are the easiest. All right? Look at the first phrase. Y varies directly with X. So right away, if Y varies directly as X, I know that I have Y is equal to Kx, and if I solve for K, K is going to be Y over X. Look at all these problems right here. What do you notice? They all have X's and Y's. Oh, wow. Okay, so on this problem, X is 24. So I'm going to put a 24 on the bottom because that's where X goes, and Y, 3 on the top. And I'm going to simplify that. Use your calculator if you need. And if you notice, K is going to be 1/8. Well, once I know K, I go back and plug it in right here, and I have my equation. This equation, Y is equal to 1/8 times X. That's my answer. That's my direct variation equation. I'm done. It's as simple as putting Y over X and then making that my slope or my constant of variation. All right? So if we try this one right here, doing the same process, K is equal to Y over X. Y is a -4. X is a -16. Reduce that. Again, use your calculator if you need to, and you get 1/4. Simply take that now. That's your slope, constant of variation. Write Y equals. Put that fraction or number down here. Put an X behind it. You don't have a Y-intercept, so don't write anything after that because it's a direct variation. There you go. Okay? So you don't always have a small number over a big number. Don't get into small and big. Just write what you have. Look at number 20. I've got K is equal to Y over X. How do I know that? Because it's a direct variation. That's the only reason I can write that down. All right? So Y is a -30. X is a 5. -30 divided by 5 is a -6. So that's my constant of variation, also known as your slope. So write Y is equal to -6x, box it in and be done.